Good afternoon, Algebra 2 students. Today we're going to talk about proving trig identities, and I like to refer to this one as the martial arts lesson. And I call it that because if you've ever taken martial arts or seen them, karate, kung fu, taekwondo, any of those, your sensei or your teacher can show you many different ways to throw a punch, many different ways to kick, many different ways to block or change direction, move out of the way, etc. And people who are very skilled in it, black belts, can do this with kind of ease. This lesson is really a black belt level lesson for mathematics. So don't be discouraged, no matter how good you are at math, if these things are difficult at first. They're supposed to be. It kind of brings you, to me, into a new echelon of it all. A few preliminary things I've written down here. They're not extremely important that you grasp all the way, but if you can follow it, just see if you know what I'm talking about. We know, for example, from the Pythagorean theorem, that a squared plus b squared equals c squared. Recently, we started talking about the unit circle and how all these little angles produce right triangles when you draw connecting lines, right? And x and y are really the sides of the right triangles in the unit circle, right? From here to here is the x value, and from here to here is the y value of that specific point. And an angle inside a right triangle, we know that cosine is equal to the opposite, sine is equal to the opposite side over the hypotenuse, and cosine is equal to the adjacent side over the hypotenuse. So because of that, x and y are really the same thing that cosine and sine are. Whatever this point is, the x value is its cosine and the y value is its sine. So we can replace a and b then with x and y, okay, because those are really the side lengths. And we replace c with r because in the unit circle, the hypotenuse, c, is really the radius of the circle, the distance from the center to the edge, which we know to be 1. That's why it's called unit circle. And if you raise 1 to the second power, you still have 1. And if x is really the cosine, then x squared is really cosine squared of, and we can talk about any given angle. This is theta, right, that they like to use a lot. Plus sine squared of theta is equal to 1. This is what's called the Pythagorean identity. And we know a lot of things because of stuff like this. This is kind of a list of a few of them when it comes to trigonometry. Earlier in class I gave you guys some more than just these, but I'm going to use these just for this example because they just a nice little starting point, I guess you would say. We know, for example, that the cosecant is equal to 1 over sine. Tangent of an angle is equal to the sine of that angle divided by cosine of angle. Pythagorean identity, its other versions. I know that anytime I encounter these situations, I can replace them with something from the playbook. And that comes in handy when you're asked to prove a trig identity. According to them, the sine of an angle is equal to the cosecant of that angle minus the cosine of that angle times the cotangent of that angle. And they're telling me to prove that. Now, at any point during this, I encourage you guys to pause it, stop, see how far you can go, and then when you're ready again, hit play, so on and so forth. But once again, it's important that I keep stressing, this is black belt level stuff. Don't be discouraged if it's hard at first, because there's not just one thing to do here and one thing to do here. There's lots of things we could do on step 1. Lots of things. I could put 30 different really good mathematicians in a room, give them the exact same trig function. They might all do something different and all prove it. Okay, and that's really difficult sometimes for students to wrap their head around. So I'm just going to look at anything I can possibly change from this right-hand side, because the goal of proving it is to make the left side and the right side look the same, be the same. Right now they're nothing alike. So can I change cosecant of an angle to something? Yeah. Cosecant of the angle I know is equal to 1 divided by the sine of the angle. So that's what I'm going to do right now. I'm just going to focus on replacing him, CSC of an angle, with 1 divided by sine of that angle. So everything else I'm going to drop. Okay. Changed one thing so far that I know to be true, that cosecant is equal to 1 over sine. Next up, anything else I could possibly replace. Okay, how about cotangent? And on this one I got an option, because cotangent shows up twice. I could replace it with 1 over tangent of the angle, or cosine of the angle divided by sine of the angle. For no particular reason, I'm just going to pick that one. I'm going to change cotangent to cosine of the angle divided by sine of the angle. Everything else I'm going to drop. Oops. So the reason I drew parentheses around this was because cosine and cotangent are multiplying each other. So I wanted to emphasize that cosine still needs to multiply this. I got cosine of the angle on top of sine of the angle for cotangent, which is what it's equal to. And where do I go from here? Well, there's lots of different things we could do, but what stands out to me right now is this part is kind of bothering me. I really want to kind of just distribute that in there, right? Cosine of an angle, theta, multiplying this fraction, it would multiply the top part but leave the bottom, because technically this is cosine over 1 as a fraction, so it's top times top and bottom times bottom. So I'm going to drop everything else. And when I distribute this, I'm going to get cosine squared of the angle over sine of the angle. Cosine of the angle times cosine of the angle is cosine squared of the angle divided by sine of the angle. So I took this expression over here to the right of the minus sign and changed it into this using some algebra. Alright, well, still doesn't look the same, so I still have work to do. The right hand side still is a fraction situation, and I have the same denominator, so technically I could subtract these, but honestly when I get up to this level I like getting rid of fractions altogether. So there is a way to get rid of fractions. Multiply the entire equation by whatever's in the denominator. If I multiply everything by what is in the denominator of these fractions, then when it goes through the distributive property and it gets here, they're going to cancel. And when it gets here, they're going to cancel and leave me with just the numerators. So that's what I'm going to do. Not that you had to do that on this step. Again, martial arts situation. You may throw a punch when I decide to throw a kick. It's just kind of up to you. But remember what the goal is. Make the sides match. So sine of the angle times sine of the angle becomes sine squared of the angle theta. Equal to, when he multiplies the fraction, they'll cancel. Leave me with 1. Over here to the right of the minus sign, they'll cancel. Leave me with cosine squared of theta. And that looks familiar to me. In fact, all that looks familiar to me as being the Pythagorean identity. 1 minus cosine squared, 1 minus cosine squared is really just sine squared. So anytime I encounter 1 minus cosine squared, which I do right here on the right, I can replace it with sine squared of the angle. The left I'm just going to drop. And I have proven this identity, because now my left side and my right side are an exact match. What I encourage you to do is practice these. If you go and just do a Google search and just type in the words proving trig identities and hit images, like not the web pages, but hit the images button where you see pictures of that search, and you will see so many of them. You're welcome to try as many of them as you want if you just want to kind of look at it and stare at it. If you feel like this is kind of a lesson that's a little bit beyond your realm, remember it's not like the next test we take is going to be all of this, but I still encourage you to try. You can learn so much from each and every one of these encounters. It really makes you good with equations and algebra. Remember that you have a playbook, that you can always ask for help whenever you need it. Have a good afternoon, guys.